Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. First of all, today I will express my gratitude to you, Honorable. I'm super happy SSI MSI, Mr. Dr. Sudi UST MSc, Mr. Muhammad Amin ST, as my advisor, and Nami Asmi MSI PhD as my senior, for giving me this opportunity to present my research funds. Before I start my presentation, let me introduce myself. My name is Sarfira Sasandra Putri with NPM 2050-704-1004. In this occasion, I would like to present research regarding the manufacturing polymer mortar using polyethylene terephthalate or PET and ethylene vinyl acetate or EVA by sodium method for 7 and 14 days. In the outline, there are three things that will be discussed. For the first, chapter 1 introduction, and for the second chapter for results and discussion, and third, chapter 5 conclusion and suggestion. And for the first introduction, a problem formulation. This research has two formulation of the problems, namely number one, how does the variation in composition and soaking time influence the mechanical properties and physical properties of polymer mortar? And for number two, how does the variation in composition and soaking time affect the chemical composition, phase structure, microstructure, and functional groups formed in a polymer mortar? And this research has to propose there are understanding the influence of composition variation and soaking time on the mechanical properties and physical properties of polymer mortar, and then understanding influence of composition variation and soaking time on the chemical composition, phase structure, microstructure, and functional groups formed in polymer mortar. And for the second, chapter 4 about the result and discussion. At the research and discussion, we have a three section. For the first, characterization of raw material, and the second, mechanical and physical testing of polymer mortar, and third, and the last, characterization of polymer mortar. And for the first, about the characterization of raw material is XRF. This is about the table XRF characterization results of sand and cement. And based on the table 1, the dominant oxide compound in cement is calcium oxide, or CaO, at 77.82%. For cement, which can be used for general construction based on SNI 157064 2004, for CaO compounds can be used, a building mixture is more than 45%. And meanwhile, for sand, the dominant oxide is silicon dioxide, or SiO2. In accordance with Preset Yarrow 2021, sand is one of the materials with the high silica content that can be used in several industrial applications, including mortar production. And then this is about the characterizations of polymer. There are EVA and PET. And for the table 2, it shows the dominant of element is PET and EVA is calcium. In EVA polymers, the calcium element content can increase resistance to water by ASAT 2018, and the CEA element in PET can increase resistance to cracking by Utomo and Alfiana 2023. And the second characterization is XRD. At the figure 1 shows the de facto of raw material. In Portland cement, the dominant paste form are calcite, hematite, calcite, and quartz. And for the sand, the dominant of paste are quartz, hematite, and corundum. And meanwhile, for EVA polymer, the dominant paste form are calcite, quartz, and hematite. And the last, for PET polymer, the de facto has an irregular shape, indicating the PET is an amorphous type. And the third, about the CMDS. In figure 2, about the Portland cement, the dominant elements are yellow as Ca elements, and Si element is purple. And exactly for, sorry, an element composition of cement, there are C, O, A, L, S, E, M, G, C, A, K, and S. And this is for the sand. For the sand, the element dominant is Se, Si, sorry, marked a purple, and Al aluminum element is blue. And there are a C, O, A, L, S, E, N, A, K, and F, A. And this is about the EVA polymer. In the EVA polymer has its dominant element Ca is yellow, purple as a Si element or silicon element, and for the magnesium mark in magenta. And polymer EVA element composition, there are a C for 57.52% and O 31.46%, and aluminum 0.43%, and silicon 1.67%, and for magnesium 3.63%, and calcium 5.28%. And this is about the PET. The dominant of PET element is Ca with the blue color and Si with the dark blue color. And then this is about FTER characterization of SMAN and SAM. For a Portland SMAN, at wave number of 3,400, there is an all-bond edge indicating a slight increase in oil content. That at wave number between 900 and 1,000, a strong asymmetric bending is observed, representing the formation of calcium silicate hydrate in the mortar. And for the sand, at wave number of 3,693, there are a O-bond edge, stretching vibration due to absorbed water molecule, and wavelength at 759, Si bond O bond Si bands are performed. And this is about the EVA polymer. FTIR and EVA polymer, the wave number 3,365 indicate the presence of C double bond O functional groups. And then for the C bond H functional group is performed at wave number 2,933. And then for the 1,233 is the C bond O functional group. And then this is for PET. In PET, in the graph, the alphametric C double bond H stretching shows a small peak at 2,969. And then for the C bond O bond C stretching in ester groups at 1,242, 2,091. And then for the C bond H is at wavelength 1,060. Okay. And next about the mechanical and physical testing. And the first is mechanical testing. Mechanical testing is compressive strength. Based on figure 9, it can be seen that variation in material by soaking time can influence the compressive strength of polymer mortar. The compressive strength of polymer mortar based on variation in soaking time has increased, while the compressive strength has decreased due to the increase in polymer substitution composition in mortar. And this is about the physical testing. There are porosity, absorption, and density. The first is porosity. And porosity and absorption has a decrease with an increase in the duration of soaking time, but increase with a rise in the polymer composition used. And then for the density, based on the variation in soaking time, has increased while the density has decreased due to the increase in polymer substitution in mortar. For the section about the characterization of a polymer mortar. So the first is XRF. Based on this table, it shows that the chemical composition is two samples dominated by calcium oxide and silicon dioxide, with a value of 35.97% and 33.61% for 7 days, and then 38.65% and 30.34% for 4 days. Okay, this is about the XRD characterization of polymer mortar. Based on the figure, this shows the defectogram of polymer mortar. 7 and 14 days, the dominant phase, there are quartz, calcite, hematite, and corundum, but the highest peaks at the calcite or calcium carbonate CaCO3. And this is about the CEM and EGS for polymer mortar 7 days. And based on this figure, the dominant in polymer mortar 7 days is Ca and Si. And for the 14 days, 2 Ca and Si with an Sca as a yellow mark, and then Si with a purple color. And this is about the FCIR of polymer mortar. The analysis results of the graph showing at wave number 3694 indicate the stretching of the all bond edge, which means the presence of adsorbed weather molecules from CSH pass or calcium silicate hydride, based on the research by Yu et al. 1999, investigating the structure of calcium silicate hydride. It is found at wave number between 980 until 1080. And then the strong asymmetric linkage toward the formation of hydride silicate calcium and polymer mortar can be shown at the wave number 103, indicating the stretching in the Si bond O band. Okay, and in conclusion and suggestion. For the conclusion, for the first, the composite strength and density increase with a longer second time, but decrease with the increasing variation in composition of polymer substitution. Meanwhile, the porosity and absorption in the polymer mortar decrease with a longer second time, but increase with the increasing variation in composition of polymer substitution. And for the second, the result of the XRF characterization showed that the dominant chemical composition in polymer mortar are CaO, SiO2, Al2O3, and Fe2O3. The result of XRF characterization showed that the best form in the polymer mortar are calcite, quartz, corundum, and hematite. But the fourth, the result of the CE and EVS characterization of the polymer mortar showed that the dominant elements are calcium and silica. And for the last, the result of FTIR characterization on polymer mortar show the presence of forms. Functional groups are She double bond She and She bond H, Si bond O, and O bond H. And for the solution for the future research is to increase the variation in stacking time for polymer mortar to achieve more optimal result. Okay, thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.